Today we're going to be using the unit circle to find two different things. One of the things that we're going to start with is looking at the unit circle, and this time instead of knowing the angle and trying to find the coordinates of the point on the unit circle, so that's what we were doing before. We would know this angle right here, and we were trying to find this point right here, the point on the unit circle. And we defined this point as the x value was the cosine of theta, and the y value was the sine of theta. We're still going to use that, but we're also going to look at how to work backwards, how to know this point right here, and work backward to find the 6 trigonometric values from the point, and not just from the angle. So when you do this, you can find first this hypotenuse right here. Okay, now we set the hypotenuse to be 1 in the unit circle, but if I change these values x and y to points in the coordinate plane, I'm going to have to work backward and find this radius. And the way I'm going to do that is I'm going to find the distance from the origin right here all the way up to the point right here. Okay, and it's going to be the hypotenuse for any angle in standard position, right? And the hypotenuse, remember, was always the terminal side. Okay, so we can write that in parentheses, terminal side. Okay. So the sine would be opposite over hypotenuse. In this case, the hypotenuse is some radius that we solve for. It's not necessarily 1. So let me show you what I mean. Let's take a look at an example where we have a point, and it's the point 1, 3. So let's draw that in the coordinate plane. What does the point 1, 3 look like? Well, let's say it lives right here, 1, 3. So that would make the x value 1 and the y value 3. And then, of course, we need to solve for this distance over here, and we would use the Pythagorean theorem. So 1 squared plus 3 squared equals r squared. So 10 equals r squared, and r equals root 10. Okay, so let's label that root 10. So this is theta. We don't know what theta is, but we don't need to know theta in order to find the sine, cosine, and tangent. We just need to know the opposite, adjacent, and hypotenuse parts of the triangle. Okay, so now we can find the sine, cosine, and tangent. So the sine of theta is going to be opposite over hypotenuse. So opposite, that's going to be 3 over hypotenuse. Okay. Cosine of theta is going to be adjacent over hypotenuse. And tangent of theta is going to be opposite over adjacent, or 3. Remember that once you find the sine, cosine, and tangent, it should be easy to find the cosecant, the secant, and the cotangent by simply taking the reciprocal of these 3. So go ahead and do that now. Okay, so we're also going to use the unit circle today to find the cosine and cosecant of quadrantal angles. So remember, quadrantal angles were the angles that fell on the axes, right? So on the y-axis and on the x-axis. And the easiest way to find the cosine of these angles is to remember where they sit on the unit circle. 0 degrees sits here, and we define the radius as being 1, so it would sit at 1, 0. 90 degrees is here, it sits at 0, 1. 180 degrees is here, it sits at negative 1, 0. And 270 degrees sits down here, it's at 0, negative 1. Okay, and then remember, we're looking for the cosine, so that's always going to be the x value of each one of these coordinate points. So the first one says find the cosine and the secant, the cosecant of this guy right here. So the cosine is going to be the cosine of 0 degrees. Where are we going to find that? So look over here at 0 degrees, I was at the point 1, 0, and the cosine is the x value, so it's going to be 1. Okay. cosine of 90 degrees, right? Now we're here. And remember, the x value was the cosine, so that's just 0. Cosine of 180, now we're here. So look again, look at the x value. That's going to be -1. And of course, lastly, we'll look here. Where's 3 pi over 2? That's at 270 degrees. So what is the cosine of 270 degrees? That's just the x value there, so that's going to be 0. So now to find the cosecant functions, we're going to need to find the sine of each one of these and then flip it upside down. So remember, the sine of each one is the y value. So go ahead and do that now. Pause the video if you need to. Find the sine value of each one of these angles and then take the reciprocal of those to find the cosecant. Okay, couple other things that the unit circle can help us with. Think about where the sine values and cosine values could both be positive or both be negative, right? Remember that the sine of an angle is just the y value. So this is like asking, where is y positive? And then the cosine, of course, is x. So where is x positive? Well, y is positive in the first quadrant. X is positive in first quadrant. Therefore, I would be in this quadrant. So we can use this information in a problem like number 4 to solve for the sine and cosine. Let's look at this problem. In this problem, we're told that the tangent is negative, and the cosine is also negative. Remember, this was the x value. So the x value is going to be negative. The tangent is always y over x, and our tangent value is negative. So if the tangent's negative and the x value is negative, that means the y value has to be positive. So here we have a quadrant where the cosine was negative, but the sine has to be positive. So let's look at where the cosine would be negative and the sine would be positive. So here's where x is negative, right, in either the second quadrant or the third quadrant. And then we need a positive y value, right? So negative x value would put us in the third quadrant. Positive y value would put us in the second quadrant. So we know we're in the second quadrant. So now we can draw our triangle. Okay, so let's draw our triangle. There's my triangle. It's in the second quadrant. Okay, and I'm told that the tangent of this angle is -1/3. So remember, the tangent was opposite over adjacent. So that means the opposite side was -1. Oh, I'm sorry, I just put that in the wrong spot. The opposite side is -1. The adjacent side, +1. The adjacent side is -3. So how do I know that the 3 is the negative side and the 1 is positive? Remember, this distance is y. This is going up 1 space up. This is going 3 spaces left. Okay, and then using the Pythagorean theorem, like we did in the first problem, I find that the hypotenuse is √10. So now I can find the sine of this angle by doing opposite, that's 1 over hypotenuse, which is √10. And the sine is positive in this quadrant. And then I can do cosine theta, which is going to be adjacent, -3, over hypotenuse, which is √10 again. So that's how I would find the sine and cosine in these two quadrants. So now let's look at reference angles. Reference angles are one of the most important tools that we have in the unit circle. Reference angles are angles that we create for any angles that are larger than 90 degrees. In other words, any angle that I can't draw into a triangle. Reference angles are angles that are created for non-acute angles. So again, angles I cannot draw into a triangle. And the reference angle is created with the terminal side of the angle and the x-axis. The biggest mistake that people are going to make is they're going to draw their reference angle with the y-axis. So take a second to either highlight this or box it or make a little note to yourself. It's got to be with the x-axis. Okay? And the trigonometric functions will always be the same for your angle as for the reference angle, and the only thing that will be different will be the sign, S-I-G-N, sign. In other words, they'll be the same, but they might be positive instead of negative or negative instead of positive. So let's find the reference angles for some of these. Let's look at this one. What would be the reference angle for 210 degrees? So 210 degrees looks like this, right? And really a reference angle is how many degrees, right, or radians past or from the x-axis. So if I'm at 210 degrees, the question is, how much further did I pass the x-axis? So the x-axis was 180, and so I would see that I went 30 degrees further than the x-axis. So that's my reference angle. Let's look at B, 7 pi over 4. This one comes all the way around, and then it's pi over 4 short of being a full rotation. So how many degrees or radians is it from the x-axis? So the reference angle here is pi over 4. Okay, let's look at 270. If you draw negative 270, you go negative 180, and then you go another 60 degrees. Now we don't really care that this is negative because the question is, how much further did I go from the x-axis? And the answer is, I went 60 degrees past the x-axis. So go ahead and pause the video again. Take a second to try to fill in D, E, and F, and then pair share. And you can check your answers on School Loop with the key. Alright, so here's how we actually use reference angles. This is when reference angles become very, very helpful. I want to find the sine of 300 degrees. I can't put 300 degrees in a circle or in a triangle, so instead I look for the reference angle for 300 degrees. 300 degrees is right here, right? It turns out that 300 degrees is 60 degrees short of being a full rotation. So I could find the sine of 60 degrees, and it would be the same as the sine of 300 degrees. So the sine of 60 degrees, if you already have these memorized, is root 3 over 2. But remember that because I'm in the fourth quadrant, look over here, in the fourth quadrant we know the y value is always negative. And since that's the sine, I know this will be negative root 3 over 2. How about the tangent of 15 pi over 4? Let's draw that in the unit circle. 15 pi over 4 is one full rotation plus a little bit, almost two full rotations. How much short of the two full rotations are we? Well, we're pi over 4 rotations short. The way I know that is because this is 15 pi over 4, and if I added one more pi over 4, that would get me to 16 pi over 4, and that would be two rotations of 2 pi. So I know I'm pi over 4 short. So that's my reference angle. That's how far away I am from the x-axis. So I could just find the tangent of pi over 4. Now pi over 4 is 45 degrees, and the tangent of 45 degrees is 1. But again, since I'm in the fourth quadrant, right, the tangent's going to be sine negative y over x, and that's going to make this negative. Let's look at C. What's the secant of pi over 6? So let's draw pi over 6. Negative pi over 6 is right here. Right? Negative pi over 6. It's just going backward 30 degrees. Well, the reference angle, it doesn't matter if it's negative or positive because it's how far away are you from the x-axis. So that's like asking what's the secant of pi over 6. So before we find the secant of pi over 6, we're going to find the reciprocal function. What's the cosine of pi over 6? So what's the cosine of 30 degrees? Well, we know that's root 3 over 2, and therefore the secant will be 2 over root 3. Since the secant and the cosine are both related to the x value, and the x value is positive in the fourth quadrant, these values will both be positive. So now for the rest of the period, try to fill in for D through I and check your answers tonight on School Loop, or you can check the key with the sub.